Hello, welcome to 13 Universal. This is A-level biology, planning, analysis, and evaluation, paper 5, series 8, and you are going to be having a wonderful time with Shedro. This is Shedro. So thank you for staying through from series 1 to 8. It's been a long journey. So this is for now the last episode. Get your materials. Let's dive in, okay? By now, you should have known that it's important to pay attention to the background information. One of the challenges of paper 5 is the bulky information. You have to think critically. And as you think through the papers, find out what, through the background information, find out what is right and what is wrong. You must think both in the positive side and negative side. You must think logically. Is that okay? So let's go. So, Baker's yeast Saccharomyces cerevisiae has two metabolic pathways for the production of aerobic respiration and fermentation. Oxygen is not used in fermentation because fermentation is actually anaerobic. These pathways are summarized in Fig 1.1. That's it. Aerobic respiration, glucose, pyruvates, acetic or ADs link reaction, glycolysis. Okay, and that is Krebs cycle. You can see this is all right. Anaerobic fermentation, alcoholic fermentation. Is that okay? All right. So let's go to the next question. Then the next page. Yeah. Remember I said it's bulky. Some students were researching details of the respiration of yeast. In their research, the student found information about the Crabtree effect. Okay, this effect occurs when yeast is kept in high concentration. Remember, pay attention, when it is kept in high concentration of glucose, the yeast gains sufficient ATP from substrate linked phosphorylation during glycolysis. Yeast does not carry out Krebs cycle oxyphosphorylation and therefore does not use oxygen. Okay, the yeast just it's okay with glycolysis because it's making a lot of ATP there, so it abandons aerobic respiration, which includes Krebs cycle phosphorylation. Is that okay? The students wanted to investigate the effect of temperature. See, the effect of temperature on the activity of yeast. All right, so which one is the independent variable here? Is it the temperature or yeast activity? Okay, so which one is affecting which one? Of course, temperature is affecting yeast activity. That's temperature is an independent variable, while yeast activity or activity of yeast is a dependent. So you measure dependent, you alter or change. All right, let's go. And decided to use these solutions in which yeast obtained all of its ATP by fermentation. So used solutions where the yeast only carried out fermentation. So the students made a suspension of yeast from 1 grams of dried yeast. So he made what? Suspension of what yeast? This is how he made it. 1 gram of dried yeast and 25 cm cube of water. The suspension was left for 2 hours at 20 degrees Celsius. After 2 hours, 25 cm cube of glucose solution was added to the yeast suspension. Some of the mixture was added immediately to the apparatus shown in Fig 1.2. The student measured the volume of carbon dioxide produced by yeast fermentation. That's it here, guys. Okay, so this apparatus gives you an idea. Okay, that is yeast suspension. This is all right, the water. All right, serving as manual water bath. This is gas range used to measure the amount of CO2 produced. So that means the yeast activity here is determined by measuring the amount of CO2 produced, okay? Because fermentation produces CO2, especially in yeast. So the more CO2 produced, the more the activity of yeast, okay? And that's temperature. So this is where they vary the temperature. All right, let's look at the next one. State the independent variable and dependent variable in the investigation here. So pause the video and write the answer. What is the independent variable? What are we changing? What are we measuring? All right. course, independent variable is temperature, that's what changing. Dependent is CO2, volume of CO2 produced, okay, or time to collect stated or fixed amount of CO2. All right, let's go. Explain why the student stirred the mixture of yeast and glucose before adding it to the tube. Right, so pause the video. Why did they stir the mixture of yeast and glucose before adding it to the tube in the apparatus? Why? Of course, is to ensure uniform distribution of glucose and yeast, uniform mixture, right? Look at it. The glucose and yeast are uniformly distributed, homogeneously mixed, evenly mixed, completely mixed. So this is very important. There must be uniform distribution so that every part of the solution has equal, all right, amount of yeast and glucose. All right, let's go. Just 1 mark for this. Now this is the big question. Okay, about 7 marks question. That's a big question. Describe a method using the apparatus set up as shown in fig 1.1 that students could use to find the temperature at which yeast carries out fermentation at its maximum rate. Your method should be set out in a logical order and be detailed enough for another person to follow. You should not include details of how to make the yeast suspension or how to set up this apparatus. Okay, yeah, so this is about 7 marks question. All right, so I want you to attempt this question. Pause the video and describe this method. Okay, all right, pause it. Now welcome back. If you have been following up, remember that you have to get an outline at one end of your paper and plan this essay, because you're writing a descriptive essay, and in that essay you must be able to identify your independent variable. Okay, so the one you're changing is temperature. Okay, and how you're going to change it, that's temperature. That's the independent variable here. So your dependent variable is what you want to measure, and of course that is in the volume of oxygen, no, volume of CO2 produced. Okay, all right, or time to measure a particular stated volume. So you must identify your key variables. What are the things that should be kept constant and how they should be kept constant? Okay, for example, the volume of yeast suspension should be the same. The concentration of glucose should be the same. The volume of both the yeast suspension and that of glucose should be the same, and the time for reaction should be the same. Okay, so type of yeast should be the same, and then you look at for reliability. These are the things you, before you start writing, take control of this. Reliability, you know, you're going to mention more replicate values and then calculate the mean, and you must think about hazard, guys. These are the things you have to consider before writing. Okay, now this is where you write your essay. You write a descriptive essay. Okay, so you start with independent variable. Now you have identified it. How are we going to change it? Remember that your independent variable is temperature. You must state some values. For example, you can decide to state values, give normal interval, maybe 5, if you like, and start with maybe 10 degrees Celsius. Okay, yeah, and then you go from 10, and then you know, go to 15, okay, 20, depending on the optimal. All right, okay, then 25, all right, so, and then 30. If you like, you can use it. The interval is 5, 30, or you can just start from 10, 20, 30, 40. All right, get 5 values. Okay, and then these values, temperature degrees Celsius, this is 10 degrees Celsius, 15 degrees Celsius, 20 degrees Celsius, 25 degrees Celsius, and 30 degrees Celsius. You have to maintain these temperatures using the water bath. Okay, because you can see the manual water bath they showed us there. Yeah, so easy to maintain it. All right, you pour hot water when it is cold. But how do you write this? Okay, so and then you just and of course this dependent variable, how do you you determine that, you measure the volume, key variable. So somebody can say, you can start by writing the same volume of um, yeast suspension put into test tube. Okay, the bottle, right, test tube, and of course same volume of glucose mixed with it, and the reaction is equilibrated. Is the mixture is equilibrated, that is given some time for like 2 minutes for it to be equilibrated, and then the volume of oxygen, CO2 produced, measured. All right, so simple as that. And of course you now state that the volume must be the same. Okay, the yeast must be the same, and then mention that the key variables, okay, that's what we're talking about. The volume, the concentration of glucose, concentration of yeast, their volumes should be the same, and then the reliability must be carried out at 3 replicates, and then mean calculated, and the hazard, the yeast, all right, could be allergic, so you wear hand gloves. Okay, and of course um and other things. So these are the things you have to consider. So these things, you transfer them here as you write here, and that's all. Okay, and then you're going to have something like this. That's it. Use minimum of 5 different temperatures. Okay, state, this is a guide, state a suitable range of identified temperature. We have done that here. Idea of same standardized known volume of yeast, must mention them as you describe it. Method of maintaining a constant steady temperature: use water bath, leave mixture to equilibrate, leave for a particular time, and then measure the volume. Time, how long to collect the volume. If you want to use time, use a control. Yes, we didn't say this. You can use a control. All right, use killed yeast or use water to replace yeast to check whether it is the yeast that is causing the production of CO2 or another factor. Now these are other things. Okay, replicate, that's reliability. You can see reliability here. Repeat investigation with narrow range. Okay, that's another way to improve reliability. Okay, low risk, medium hazard, the steady risk, this allergy, return gloves. Okay, that's it, guys. It's very simple. Practice it. Okay, the pH also should be maintained. 7 marks. Okay, let's go to the next role. Scientists have discovered that some other species of yeast show the crab tree effect. The crab tree effect means that in concentration of glucose with oxygen present, pyruvate is not metabolized. Imagine mitochondria in mitochondria, so aerobic respiration does not occur. That's quite amazing. Okay, now that's high glucose concentration. Yeast species that are able to maintain their levels of ATP production when conditions suddenly change and no oxygen is available show the crab effect. See where it is. So you have to pay attention to this. You must pay attention, you must read in between lines and think critically. All right, yeast species that are able to maintain their levels of ATP, they're doing well, ATP production, when conditions suddenly change and no oxygen is available show the crab effect. That means if we remove oxygen and they still maintain high level of ATP, that is all right, ATP production. And how do you know high level of ATP production? How do you measure it? How do you measure activity of yeast here from the experiment? You know it by measuring the volume of CO2 produced. That means that if we switch the yeast from um, having oxygen to not having oxygen and still the amount of CO2 produced is still high, that means it has shown crab effect. So you can do without aerobic respiration. You have to interpret all of this. Now, 3 flasks containing suspension of S. cerevisiae with yeast Candida tropicalis to see if they, so there are 2 yeasts here, okay, Saccharomyces cerevisiae and of course Candida tropicalis, to see, they will not compare 2 of them to see if this other species also shows the crab effect. 3 flasks containing suspension of S. cerevisiae in a growth medium were initially kept in different conditions for growth, After a set of time, the yeast in each flask was transferred. So what they did was transferred to a flask containing a fresh medium with high glucose concentration and no oxygen. Yeah, that's experimental condition. So it transferred. Now, all other conditions were standardized. The same procedure was repeated for C. tropicalis. The conditions for growth and experimental conditions in the flask are summarized in table 1.1. Where is it? This table 1.1. This is normal condition for growth. High glucose concentration with no oxygen. High glucose concentration with oxygen. Water, no glucose with oxygen. So this is experimental. So after some time, each of these was moved to this condition. So with glucose, high concentration with no oxygen, all right, so each of them was moved to this. So any of them that maintains high ATP production, like said here, all right, even in the absence of oxygen, has shown Crabtree effect. So you must understand what the concept is all about. Okay, yeah. So see, samples taken from the flask kept in experimental conditions here were put into apparatus shown in Fig 1.2 to measure the volume of carbon dioxide produced by the two yeast species. You know them, the S. cerevisiae, Saccharomyces cerevisiae, and Candida tropicalis. The results are shown in Fig 1.3. Okay, the final volume of carbon dioxide produced by the sample of yeast from flask 1 at 30 minutes is shown as a maximum volume, okay, of 100% in Fig 1.3. All other volumes were calculated as a proportion of this maximum. This allows a direct comparison to be made between two species. Okay, that's it, guys. So this is experimental biology, and we have to pay attention to data. Okay, you can see that this is for S. cerevisiae. There's the graph. This is for tropicalis. You can see flask 1. Okay, flask 1 has high, of course, like you said, they both have high glucose concentration and of course oxygen there, right? Two of them are reached in 30 minutes. They reach 100%. But now let's go to flask 2. Right, flask 2 is where they were moved. Of course, yeah, of course, there was a change there, and then it was moved, and they found out that, look at it, when they moved it from experimental normal growth conditions to experimental condition, you see that this S. cerevisiae maintained high ATP production. How do I know? Do you see that if you measure this? Okay, look at this. Each box is about 2, right? Yeah. So this is about 93, yeah, percent. But this, when it was the flask 2, is what shows us what it's all about. This is 60. That's like about 60, 65 or thereabout. Yeah. So do you see that this dropped from 100 to 65? There was not much drop. It still maintains high. Okay. Of course, this also drop. Okay. So this shows, of course, Crab's effect. So this is not able to switch from aerobic to anaerobic when oxygen was removed. Okay, but this was able to switch from aerobic to anaerobic when oxygen was removed. Okay, so this showed Crab's effect. So as you are reading the background information, connect it to your data. All right, look at it. State and explain the evidence in Fig 1.3 that support the ideas that C. tropicalis does not show Crab's effect. Now I want you to write it down. Okay, I've done some explanations. All right, I think they say you should state the evidence. So you can see that in flask 2, this maintains high concentration of CO2 volume, which is about 93 or thereabout, but this reduced. Okay, the volume of CO2, maximum volume of CO2 collected for C. tropicalis reduced from 100 to like 63 of thereabout, 60, yeah, 64% of 5. So we have stated it, but the question says, and explain why did it drop? This didn't show it, okay, because it doesn't maintain high ATP production, but this shows it. Why? This is able to carry on with ATP production in the absence of oxygen, but this, all right, is slow in changing from aerobic to anaerobic, all right, respiration. So that's why it dropped. So there was no Krebs effect here. Okay. Okay, let's look at what I said here. Okay, look at this is the answer. Flax 2 provides evidence as in C. tropicalis there is low CO2 production. That low CO2 production shows that there's low ATP production. Okay. All right, because CO2 is used to measure yeast activity. Now for flax 2, C. tropicalis compared to 65% for this, you can see this versus 93%. Okay. You can see after 30 minutes. All right, guys. Idea that this explanation, idea that when transferred from condition with low condition with oxygen to condition with no oxygen, yeast have to use fermentation. Yes, anaerobic respiration. Of course, you can see C. tropicalis does so at a much slower rate as no Krebs effect, thus less CO2 produced. You can see that. All right, so that's 3 marks. A lot. Yeah. Now, this is another question. Species diversity is often used as a sample to compare. Species diversity is used as a simple way to compare the biodiversity of different regions of the world. So that means if you have higher species diversity, that means the biodiversity is high. Species diversity, different number of species. Have different number of species, all right. You know, different number of species means that we have a lot of course, we have biodiversity. A student read okay, read that species diversity decreases with increasing distance from the equator. So now this is, I want to imply inductive reasoning here. So inductive reasoning is that it's telling us that, you know, there's a correlation between species diversity and increasing distance from the equator, and that correlation is a negative one. That's what the guy is implying, guys. That's what the student read, that species diversity decreases with increasing distance from the equator. There's a correlation here. It might not be causal, all right, but it's telling us that there's a negative correlation as distance from the equator increases species diversity. Okay, let's find out, because now what we'll do as scientists, we want to find out whether this is correct or wrong. The latitude at equator, this is background information, is 0 degrees. Latitudes increases north and south of the equator. Yeah, the student selected data. See, I want you, as you read all of this, find out what is right and what is wrong, because you may be asked to evaluate or assess anytime you're reading background information of how people or another person carried out an investigation, experimental investigation. As a scientist, we must be objective and logical. So you find out what they did right and what they did not do right. Okay, so that when you're asked to evaluate, to judge, to assess, you know, you have what to say. Okay, so this is what training you on that scale of evaluation. Okay, so they can discuss properly. All right, now let's see. The student selected data from a this will got a database which holds records of annual birth count in North America. This annual count is carried out each year during one day in the winter. Did you find something wrong here? Okay, it's done each year, that's good, but did you see any reliability from here? During only one day in the winter. Why is it only one day? This is not reliable. See? Okay, reliability has to do with repetitive, right, or producing more replicate value. Why only one day? Okay, so just take note of that. Now let's go on. Volunteers count all the species of birds that they observed in each location. So they count all different species of birds that they observe. Can you see, is anything wrong with that? there are two things wrong with this. Write down what you feel that's wrong with that. Number one thing that's wrong with that, they said count all species. Now, it's not easy to count birds, all right, as they fly over. They fly over you, or you see them flying. It's not easy to count them, all right. It's difficult. There'll be errors made in counting them. And again, because we are thinking about biodiversity, you may not be able to note down the individual, okay, for each species of birds, the number of each species or their relative abundance for each species, because we are bird species. Species A, species B, species C. So just counting whether it's species A or B or C, they just counted it, right? They did not count the number of each species, and it was only bird species that we're using here, not no other animal, all right, no other organism that's being used. The area of each location is the same size, okay? Now they did this well, right? All right, the student found data from 17 sample location with Dalmava Peninsula on the east coast of USA for 2005. Okay, that's it. Fig 2.1 shows the 17 locations with, okay, Dalmava Peninsula. So these are the 17 locations, 1, 2. But what do you find about these locations? Okay, so you have to think critically. What is right and what is wrong? That's what we're trained to do as scientists. Okay, yeah. See this location. This is 39. All right, north. Okay, this is 38 north, only north. All right, so we didn't count the ones before 40 and above, and didn't count the ones 37 below. Okay, so this is not enough, all right, evidence of the biodiversity. But anyway, we did 1, 2, 3, 17 is fine, but it's just that since we are linking it with latitude, so latitude, all right, above 40 or 40 and above is not considered here. It will affect it. Below 37, so you have to be critical in your thinking. All right, the student used the data to see if there was any relationship between latitudes of the sample locations and the number of species recorded at each location. So trying to do this. The data are shown in Fig 2.2. So let's see Fig 2.2. Okay, so this is latitude increasing. This is number of species. What's happening to that? Let's look at it. So describe the trend shown by the scatter graph. This is scatter graph. So I want you to try it. Pause the video and describe the trend. What is the trend? And if you check, it seems there's no clear trend. But if you check, as this increases, right, as latitude increases, can you see? This was this. There is a slight decrease. Okay, all right, slight decrease. All right, so you see, if you said idea of no clear relationship, you are correct, no clear. But if also as latitude increases, bird species diversity or number of birds slightly decreases, you're also correct. Okay, might show downward trend, you're also correct, because yeah, shows it 1 mark. The students analyzed the data using Spearman's rank correlation test. Spearman, you know Spearman, right? State 3 reasons why this statistical test is a suitable way to analyze the data about species diversity. So, what are the criteria? That's what they're asking you. Why do we use Spearman? What are the criteria? Okay. Number 1, I feel, but write it down. Why should I take the answer? You write it down, okay? Yes, that's how we work. Try it first, pause the video and try, pause the video and try, PAT, pause and try, pause and try. Okay, now when do we use Spearman's rank correlation? Okay, of course, when we have a set of data, right, that can be ranked. That data can be ranked, and of course you can see that that data was random. When we have a set of data that was randomly selected, so if you notice it was randomly selected, we didn't follow a particular if you check the latitude, and if you check the birds, the way they counted the birds, it wasn't in a pattern, random. and that's randomly selected, and if you check, you see that the scatter graph suggests that might be a correlation, suggests there's a correlation. So if the scatter graph suggests there's a correlation, a relationship, you can use Spearman. All right, okay. So, and of course you check, there's no normal distribution there, and the data set is above 5. Okay, look at it here, guys. Data for latitude now is paired. Now they are paired. Yeah, we have set of paired data. Yeah, number of birds, latitude, point to samples are independent of each other. They're independent of each other. So it's causal relationship. It's not, sorry, it's non-causal. Now look at the data is ordinal at interval. This can be ranked. Scatter graph suggests a decreasing relationship. There are 17 pairs, more than 5 pairs. The bird species selected randomly, so bird species are counted randomly. So this is, so memorize this, okay, for Spearman. All right, 3 marks. State the null hypothesis for this investigation. Pause the video, try it. What is the null hypothesis? Right, remember that the null hypothesis is always a negative hypothesis. What we're looking for is a correlation. So null hypothesis states that there is no correlation between the bird species or biodiversity and latitude. Okay, that's what the guy says. There's no correlation between latitude and number of bird species. No, he always goes no, negative guy, right? Negative statement. All right, the student calculated the value of Spearman's rank correlation. Okay, this is the calculated value. Calculated value is minus 0.359. Table 2.1 shows the probability table for Spearman rank correlation test. Where is it? Yeah, it shows up. All right, this number of pairs. How many pairs we have here? 17. Yeah, it's critical values. And you know we normally use this. This is critical. I can use this, but you also use this. So this is our tabulated. Okay, let's see what they're asking us. So they discuss with reference to table 2.1. This is 3.1. The conclusions that can be made from the analysis or data collected. Remember, guys, I used to say it. This applies for both t-test, chi-square, and Spearman. All right. That if, for example, your Spearman, if the Spearman, this is Spearman, right? This is Spearman. S, that's S. If the Spearman calculated value of Spearman is greater, if it is greater than Spearman, right? That is Spearman, okay, tabulated tab value, the one in the table, at critical probability of 0.5, if it is greater than this calculated, then what you do is that you reject null hypothesis. Reject null if this is that. All right, reject. No, sorry, this is reject. Reject null hypothesis. Null hypothesis is represented using this. Okay, reject null hypothesis. I think this is okay. Yeah, reject null hypothesis. Otherwise, accept it. All right, that means that if it is not greater than it, accept it. Okay, but if it's greater than, if the calculated, now let's check. Let's start from there. Calculated is minus 0, okay, point 3. This is 359. Yeah, that's the calculated. So let's go to tabulated. Remember that our tabulated is pairs, 17 pairs. Go to this, right? So that's 0.485. okay, that's the measure tabulated. If you at critical probability of 0. All right, this is it. So okay, so tabulated is 0.485. okay, 485, 0.485. So check it. All right, this is not greater than this. So as a matter of fact, the calculated is less than the tabulated. So now you can't reject null hypothesis, you accept it. Okay, so you accept null hypothesis. All right, and what it means that there is no significant correlation. No significant correlation between latitudes and bird species. Okay, that is what they're asking us here. Or if you look at this, you can see that this 0 minus 0.3, because the value is usually between -1 and +1. Okay, yeah. Now the 0 here means no correlation. All right, no correlation. Okay. Of course, somebody can also interpret that this is towards negative. So this is, someone can say there's a weak correlation, very weak, because weak means it's far away from -1. It's closer to 0. This is closer to 0. So if you're going to consider it as correlation, there's a weak one, weak negative, because of negative sign. All right. Yeah. If you look at it from that angle, that's it, guys. This is what the authority says. Okay. Any fall from critical value for this is this. Of course, we've mentioned that critical value for this. Of course, they're also compared with 0.01 is that. Now, value of calculated is less than critical value. Therefore, no hypothesis is accepted. And what does that mean? There is no significant correlation between latitude and number of bird species, or there is a weak negative correlation between latitude. You know that, okay? All right. For solid marks, the student was investigating the statement species diversity decreases with increasing distance from. Okay, discuss limitations of the sampling method. I said it, and of the data collected in supporting this. So sampling method, how did they get the um, gather the information? Okay, sampling method using only one bird, one species, right? um Sorry, bird species. You're counting only bird species, is not right. Okay, so if you really want to check biodiversity, and if you really want to check biodiversity, you should sample to get this each of the species, the relative abundance. Okay, now, and of course, the data, you're going to find out that, right, it was only in one place. So one day in the winter. Okay, that doesn't give reliable result. Okay, so look at it here. Yeah, so limited only used count of birds. So you just counted birds as a sampling way. Why don't you trap them, counting them? And of course, as you're counting them, you did not check the relative abundance of each. Decisions of sampling, how to identify birds, because you're going to count them over. We mentioned it at the beginning, missed birds that fly away. So you're supposed to trap these birds and count them. Only resident bird species counted. So those birds that migrate, you don't count them. So this will make, right, this not reliable, the results. Latitude sampled. Now look at latitude now, checking that. Nothing above 40 knot, nothing above 37 knot. Okay, need a wider range of latitude. Yes, that's it. Okay. No data on latitude south of the equator. So that is it, guys. Let's go to this. Now look at it more. There's no random sample in locations. Okay, peninsula. So look at no information on habitat. These are the factors that can affect it. Only sampled on one day. So you see, these are things that could make that result not valid, okay, or reliable. So as a scientist, you have to spot them out. Okay. So this is the last question. Small birds such as ruby-crowned kinglets, Ruglus calendula. Wow, what a name, cute name. Are found throughout North America. I want to go there and find this bird. Watch it. Fig 2.3 shows a ruby-crowned kinglet caught in a mist net. Okay, mist nets are used in survey of birds population. Okay, look at this cutie. You are trapped, man. Very fine birds. Okay, that is not kinglet, ruby crown kinglets. So what is the question? Describe, show us how the mark release recapture recapture method can be used to estimate the population size of small birds such as a ruby crown mite, okay, or kinglet. So guys, pause the video and try this. Okay, remember, first of all, you use trap this net, trap the population, trap birds, All right, so when you capture them, you count their number first. Okay, when you count their number, then you release them, allow them. Now when you count their number, you don't just release them, mark them, because it says mark release. So when you capture the first population, count the number of first population, okay, is n1. Okay, yeah, then you mark them using okay, dice that do not endanger them, that do not put them at risk of survival. Then release them to mix with other birds. Within 24 hours, you now set another trap and then recapture them. When you recapture them, you now count the number of birds, all right, in the second sample you recapture. That's N2. Okay? But you now count the number of marked birds in the second sample. That is N3. Right? So to estimate the number of the birds there, okay, see, this is called Lincoln's index. Now the number of birds in the first population, first sample, captured and marked, times the number of birds captured in the second sample, all over the number of marked birds in the second sample. All right, that gives you the estimated population. Remember, okay, catch birds within an area, count total capture. Okay, that's total capture. Mark them and release them. Okay, details, marking technique, not harmful, too obvious. Okay, idea of giving time for population to mix before sample. Okay, days or weeks, not more. Okay, catch second sample and count. Second sample, that's it. Okay, the number of marked birds, that's it. Okay, that's called Lincoln's Peterson index. All right, thank you. That's 3 marks for hanging out with us. Oh, we've come to the end of V5 for now. We'll continue some other time. So we're going into topicals for AS paper 2 and paper 4. This is Shedro. Okay, share our videos, like it, follow us, share. Okay, comment. Bye for now.